So here we're going to hone in specifically on the horizon system of measurement and what altitudes really are. So again, we're just going to draw a U right here. If this is U and we're using the horizon system of measurement, again, first of all, what this means is that where the North Pole is does not matter. So I'm just going to draw it right here so we kind of have an idea that this is the axis. Here's north, here's south, meaning this faint line, I'm going to keep it faint so it doesn't distract you later, that's the equator on the Earth, and the celestial equator that exists on the celestial sphere as just being the projection outward from the equator on the Earth, but does not have any bearing on you specifically. I'm just leaving it there so you kind of can see that. Remember, what this horizon system is based off of is your position. So you go straight up from your position to the point on the celestial sphere that's directly above you, and that's your zenith. I misspelled that. You go straight down, and it's off the page, but the nadir is down here. Not really important. And then exactly 90 degrees of arc in every direction. Obviously this is two-dimensional, but in all directions, exactly 90 degrees from that gives you the celestial horizon. And all that is any point 90 degrees from the zenith. It doesn't have any truer meaning than that. It's defined from the zenith away to you to split the celestial sphere perfectly in half. And you're just working now off of this half here. Like I mentioned in the last video though, when you're looking out on the water, you can see more than half of the sphere. Because if you see here, your field of view is like that. So technically all of this is in view and only this much is obscured by the curvature of the Earth. So while that is the celestial horizon, that's the visible horizon. It's part of why why the horizon, realistically, you can kind of see the curve on your own looking out in the water. Now that might be an optical illusion, but you can envision it as being the result of that, of you being able to see further past the curve than just perfectly 90 degrees. So one of the first things you'll do in any problem is you'll correct your shot to go from the visible horizon up to the celestial horizon. It's usually not a substantial difference. It's pretty small considering how huge the scales we're working with here are. But any body, when you take a measurement of it, is going to obviously be this angle here when you physically measure it with the sextant. Because what the sextant does is it just measures the height from the horizon to the body. So that would be from your visible horizon up to the body. You would then correct for the celestial horizon, remove this much of the arc, and get this. Before we go any further, this larger angle here would be called HS, all the way from the visible horizon to the body. This would be called the sextant height. That's why it's HS, height from the sextant. Height and altitude can be used interchangeably here. And then once you correct off of the visible horizon part and just get from the celestial horizon to the body, that would be HA, which is applied height. I believe applied. Either way, that's the one that we can actually use for all of our calculations here because it still hasn't gotten all the proper corrections yet, because that's a time for later. But HA is now still corrected to within our horizon, our celestial horizon. So it's kind of more mathematically representative of the situation. Now, an important thing to note about concentric spheres like this is that any distance of arc along this sphere can be projected down onto the smaller one. And even though overall this is a much larger distance than this, they're the same arc. So if we go down to the center of the Earth here, this angle is the same as this angle and the same as this angle. This might be fewer nautical miles than this, but this is all, say, 5 degrees. This is 5 degrees. This is 5 degrees. What that means is that if you take any angle of arc that you've measured off of the celestial sphere, you can think of that almost as a distance on the Earth. So this distance here from the celestial horizon to the body could be projected down onto the Earth as the distance in arc between the point 90 degrees away from your position in any direction along the surface of the Earth to the point where the body is. You wouldn't know the exact distance, but you know its angle, and you could then just, because the angle is in degrees, multiply by 60 and get the number of nautical miles. That's a useful example, but that's not actually important to you in any way, because that's just the distance of something 90 degrees of arc away from you to the body. It's not doing anything for you. But this is, right here, the distance from your zenith to the body, because your zenith is equivalent to your position. It's just your position on the celestial sphere, not on the Earth. So this angle here is not your distance from the body, because obviously it's thousands of miles, thousands if not millions of miles, depending on how big you want to make the celestial sphere in this case. But it is the same amount of arc. So if this comes out to be 60 degrees of arc here, this down here is 60 degrees of arc as well. And that is the distance from you to where you could project the body down onto the Earth. So the body's geographic position. That's your total distance from it. And that will become important when you, later on. And you can see that that's actually just finishing out this total curve from the celestial horizon up to the body being HA, and then from the body up to your zenith. This is technically called the zenith distance, or ZD, right there. Meaning, this will be really important for later, but ZD is equal to 90 minus HA/HO. I haven't gotten to HO yet, but HO is just correcting it to be even more accurate, to actually be based off of the center of the body, not the bottom or the top of it. But HA, or zenith distance, is equal to 90 minus, we'll go with HO here. Meaning fundamentally, if you use a sextant and you measure the angle between the body and the visible horizon, and then you correct it from the visible horizon to the celestial horizon, so you get the angle between the body and the celestial horizon, you just need to do 90 minus that, and that will give you the angle between your zenith and the body, which, while it's its distance away from you, you still don't necessarily know where it is, but you can imagine that you're now pretty close along the track of being able to calculate your position.